Estimate required read and write capacity units, RCUs and WCUs, based on expected workload. Over-provision capacity to handle bursts in traffic and spikes in workload. Use on-demand capacity mode for unpredictable workloads and provision capacity mode for predictable workloads. Monitor and adjust provision capacity to handle changes in workload and avoid throttling. Enable auto-scaling to automatically adjust capacity based on workload demand. Configure auto-scaling policies to scale capacity up or down efficiently. Use provision capacity wisely to minimize costs and optimize performance. Monitor DynamoDB capacity metrics and usage to identify bottlenecks and optimize provisioning. Leverage AWS Trusted Advisor to analyze DynamoDB capacity usage and make recommendations for optimization. Monitor and optimize table and index sizes to avoid exceeding storage limits and incurring additional costs. Indexing strategies. Choose appropriate primary and secondary indexes based on query patterns and access requirements. Use global secondary indexes, GSIs, for flexible querying on non-primary key attributes. Use local secondary indexes, LSIs, for querying on non-primary key attributes within a partition. Understand the limitations and trade-offs of GSIs and LSIs, including index size, query flexibility, and consistency. Avoid over-indexing to minimize storage costs and improve write performance. Consider using sparse indexes to reduce index size and improve query performance. Create GSIs or LSIs only when necessary to avoid unnecessary overhead and maintenance. Monitor index usage and performance to identify opportunities for optimization. Use projection expressions to specify which attributes to include in index projections for efficient querying. Query optimization. Design tables and indexes to optimize query performance based on access patterns. Use key conditions to efficiently retrieve items based on primary key attributes. Use filter expressions to further refine query results based on non-key attributes. Optimize queries to minimize read and write operations and reduce costs. Batch read and write operations for efficient data retrieval and manipulation. Use parallel scans for large tables to improve scan performance and reduce latency. Optimize queries for selective filtering to minimize the number of scanned items. Leverage query caching mechanisms such as Amazon DynamoDB Accelerator, DAX, for read-heavy workloads. Implement fine-grained access control to restrict access to sensitive data and prevent unauthorized queries. Use AWS Identity and Access Management, IAM, policies and conditions to control access to DynamoDB tables and operations. Data modeling and normalization. Normalize data to reduce redundancy and improve data integrity. Use single-table designs to simplify data modeling and optimize query performance. Group related data together within a single table to minimize joins and improve query efficiency. Use composite keys to model hierarchical relationships between items. Consider data access patterns and query requirements when designing table schemas. Optimize data models for read and write patterns to minimize latency and maximize throughput. Understand the trade-offs between normalization and denormalization in DynamoDB data modeling. Implement data partitioning strategies to distribute data evenly across partitions and avoid hot partitions. Use sharding techniques to distribute load evenly and improve scalability. Monitor partition usage and distribution to identify hot partitions and optimize partitioning strategies. Use adaptive capacity features such as on-demand capacity mode and auto-scaling to handle uneven workload distributions. Data ingestion and migration. Use batch operations for efficient data ingestion and manipulation. Use parallel scans for large-scale data migration and synchronization. Consider using AWS Data Pipeline, AWS Glue, or other data integration services for data ingestion and migration. Implement data validation and error handling mechanisms to ensure data integrity during ingestion. Monitor data ingestion performance and throughput to identify bottlenecks and optimize workflows. Use AWS Schema Conversion Tool, SCT, or other migration tools to convert and migrate data from relational databases to DynamoDB. Implement data backup and restore strategies to protect against data loss and ensure data durability. Leverage AWS Backup or AWS Data Lifecycle Manager to automate data backup and retention policies for DynamoDB tables. Security and compliance. Encrypt data at rest using DynamoDB encryption at rest to protect data stored in DynamoDB tables. Use AWS Key Management Service, KMS, to manage encryption keys securely and control access to encrypted data. Encrypt data in transit using HTTPS endpoints and SSL/TLS encryption to protect data during transit between client applications and DynamoDB. Implement fine-grained access control using IAM policies and conditions to restrict access to DynamoDB tables and operations. Use AWS Identity and Access Management, IAM, roles and permissions to control access to DynamoDB resources based on user roles and responsibilities. Implement data masking and obfuscation techniques to protect sensitive data from unauthorized access. Implement audit logging and monitoring to track access to DynamoDB tables and operations and detect security incidents. Implement data retention and deletion policies to comply with regulatory requirements and protect privacy. Monitoring and alerting. Monitor DynamoDB performance metrics using Amazon CloudWatch to track throughput, latency, and error rates. Set up CloudWatch alarms to alert on thresholds for capacity utilization, throttling events, and latency. Monitor CloudWatch dashboards for real-time visibility into DynamoDB performance and usage. Use AWS X-Ray for distributed tracing and performance monitoring of DynamoDB requests. Implement custom metrics and logging to capture application-specific performance metrics and events. Set up notifications and alerts for critical events and incidents using Amazon SNS or AWS Lambda. Monitor table and index sizes, read and write capacities, and throughput to identify bottlenecks and optimize provisioning. Cost optimization. Monitor DynamoDB usage and costs using AWS Cost Explorer and AWS budgets to track spending and usage trends. Analyze cost allocation tags to attribute DynamoDB costs to specific projects or teams. Use reserved capacity pricing options to reduce DynamoDB costs for predictable workloads. Optimize provision throughput to minimize costs while meeting performance requirements. Leverage on-demand capacity mode for unpredictable workloads to avoid over-provisioning. Implement cost optimization strategies such as data archiving, tiered storage, and data lifecycle management. Review and optimize table and index designs to reduce storage costs and improve efficiency. Monitor and analyze cost-saving opportunities such as unused capacity, idle resources, and inefficient queries. Performance tuning. Use partition keys and sort keys effectively to optimize query performance and minimize latency. Monitor and optimize partition usage to distribute load evenly and avoid hot partitions. Use adaptive capacity features such as on-demand capacity mode and auto-scaling to handle dynamic workloads. Tune read and write capacities based on workload patterns and usage trends to optimize throughput and latency. Optimize queries for selective filtering to minimize the number of scanned items and reduce latency. Leverage query caching mechanisms such as Amazon DynamoDB Accelerator, DAX, for read-heavy workloads. Implement fine-grained access control to restrict access to sensitive data and prevent unauthorized queries. Use AWS Identity and Access Management, IAM, policies and conditions to control access to DynamoDB tables and operations. Backup and recovery. Enable point-in-time recovery, PIDR, to create continuous backups of DynamoDB tables and enable point-in-time recovery. Implement backup and restore strategies to protect against data loss and ensure data durability and availability. Regularly test backup and restore procedures to ensure they meet recovery time objectives, RTOs, and recovery point objectives, RPOs. Monitor backup and restore operations using AWS CloudWatch to track progress and status. Implement data retention and deletion policies to manage backup storage costs and comply with regulatory requirements. Documentation and training. Document table schemas, index configurations, and access patterns to facilitate collaboration and knowledge sharing. provide training and resources for developers, administrators, and stakeholders on DynamoDB best practices, features, and usage patterns. Maintain up-to-date documentation and knowledge bases for troubleshooting, optimization, and best practices. Stay informed about the latest features, updates, and best practices for DynamoDB by regularly reviewing AWS documentation, blog posts, white papers, and announcements. By following these best practices, you can design, deploy, and manage DynamoDB tables effectively, ensuring they meet the performance, scalability, availability, security, compliance, and cost requirements of your applications.